Good morning, children. This is 12th Physics, chapter number 9, Ray Optics. Today's topic is lens equation. So we are going to derive the lens equation for convex lens and then for concave lens. So lens formula, as we know, it is a relation between the focal length, the image distance and the object distance. Focal length f, the image distance v, and the object distance u. So let's start with it. So as you can see, children, that this is your convex lens, right? Here we are having an object that is AB. Now for drawing the image, we are going to draw one ray which is parallel to principal axis. So after refraction, it will pass through principal focus. Let's draw the second ray through optical center, which will pass undeviated. So as we see, both the images, they are meeting at this point. So this is the image for A. So A dash B dash is the image formed for the object that is AB. So as we can see that the image that is formed is due to the actual intersection of the rays. So it is real and inverted, right? And as we see, the object image is formed between the center of curvature and the principal focus. Between that, the image is formed, right, children? Now here we are going to apply some geometry. So as we know the concept of similarities, right? Similar triangles. So in similar triangles, we know that when two triangles are similar, the ratio of their corresponding sides are equal. उनकी जो corresponding sides होंगी, उनका जो ratio करेंगे, that will be equal. So here we are going to consider the triangle, and that is triangle ABO, and the other triangle is A1 B1O. Right, now these two triangles, as we can see, children, here the angle is 90 degree, here it is 90 degree, right? These are the vertically opposite angles, angle O, right? And if two sides of a triangle are equal, then obviously the third side, that is angle A and A dash, will be equal. So by the A condition, these two triangles, they are similar, right? As they both are similar triangles, the ratio of their corresponding sides. So triangle ABO and A1B1O की corresponding sides देखते हैं बेटा. AB upon A1B1 is equals to OB upon OB1. This is equation number 1, right? Now again we are going to apply the same concept of similar triangles, and now we are going to consider triangle that is EOF, and the second triangle is A1 B1 F. These are the two triangles. Now again you can see that here it is 90 degree, 90 degree, angle O is 90, angle B1 is 90, angle F, they are vertically opposite angles. Here angle F, here and here it is again angle F, right? They are vertically opposite angles. So as two angles of a triangle are equal, the third angle has to be equal. So by AAA, these both triangles are similar. So their corresponding sides. So the corresponding sides. So let's talk about the corresponding sides. So corresponding sides means EO and A1 B1. So EO upon A1 B1. These are the perpendicular, right? And the base is OF and FB1. So OF and FB1, they are equal, right? Now children, if you look carefully, then EO and AB, aren't they equal? Because what we had done, this is what? This is a parallel to principal axis. So this forms a rectangle, and rectangle, we know opposite sides are equal. So EO will be equal to AB, right? EO will be equal to AB. So AB upon A1 B1 is equals to OF upon FB1. Now if you see the left hand side of equation 1 and 2, they are same, that is AB upon A1 B1. So we can equate their right part, that is OB upon OB1 is equals to OF upon FB1. So this is it. Now let's substitute the values, the symbols, right? OB, what is OB? OB is the object distance u. So OB की जगह हमने U लिखा, but according to the sign convention, it will be minus U. OB1, isn't it image distance? So it will be V. OF हमें पता है focal length, it is on right side, so it is positive. Now, FB1 means this, right? FB1 means this. So can I write OF plus FB1 is equal to OB1, right? Now OF is what? F. FB1 we don't know, we are writing as it is, and OB1 is the image distance, that is V. So can I write FB1 equals to V minus F, right? F will go that side, it will become negative, so it is V minus F. Now if you solve this will go on this side, V will go on that side, you will get this. Dividing this equation with U, V and F, you will get this equation, and rearranging you are going to get the length equation, that is 1 upon F equals to 1 by V minus 1 by U. So I think this was very simple, it is clear. Now let's derive the length equation for the concave lens. So children, as you can see, this is a concave lens. This is the object A. We are drawing one ray perpendicular to the principal axis, and it is going to get deviate, it is going to get diverged, right? If we extend them, it is going to appear to pass through focus. वो तो होगी because it is parallel, incident ray is parallel to principal axis. Second, they will draw from optical center. They both are intersecting at this point. So the object AB image will be formed at A1, B1, right? So the distance, that is OB, is the object distance, that is on left hand side, so it is minus U, right? The image distance, that is B1O, again it is on left hand side, so it is minus V, right? Next, OF is the focal length, again it is on left hand side, so it is minus F. This much clear? Now we are going to consider two triangles. First triangle is ABO. The other triangle is, children, A1B1O. A1B1O. Now we are going to prove that they are similar triangles. So 90 degree, 90 degree, right? This is common. ABO and A1B1O. So angle O to common ho gaya na? So that is equal. And if two sides of a triangle are equal, the third side has to be equal. So by AAA, these two triangles are similar. And as these two triangles are similar, the ratio of their corresponding sides are equal. Okay, so let's see the ratio of their corresponding sides. So first, what we are going to consider? We are going to consider the perpendicular. Perpendicular इसमें है AB, इसमें perpendicular है A1 B1. So AB upon A1 B1. Now let's consider their base. इसका base क्या है? BO, और the second triangle का B1 O1. So OB upon OB1, right? Now we are going to consider the other two triangles. Now we are going to consider the triangle that is DOF, and triangle, the second triangle which we will consider is A1B1F. So F common, F angle is common, and here we are having 90 degree, 90 degree. So two sides of a triangle are equal, two angles of a triangle are equal, third angle has to be equal. So again by AAA, triangle DOF and triangle A1B1F, they are similar triangles. So the corresponding sides will be, ratio of the corresponding sides will be equal. So let's see. Base. So first we'll talk about perpendicular. Perpendicular, right? Perpendicular, okay. Yes, let me use this color. Perpendicular of triangle DOF is DO. Perpendicular of triangle A1B1F is AB1. So DO upon AB1 is equal to their base. Base of triangle DOF is OF. OF upon base of triangle A1B1F is B1F, right? Now children, if you see carefully, isn't DO equal to AB? Yes, because this is parallel to principal axis, so this is rectangle, and this will be equal to this. So instead of DO, we are going to put AB. So this equation and this equation, their left hand sides are same, so we can equate their right hand part. So on equating their right hand part, we will get OB upon OB1 equals to OF upon B1F. Now let's put the value of OF, OB1, OB. So OB is object distance, that is minus U. OF is focal length, that is minus F. OB1 is the image distance, that is minus V. And B1F is again B1F. Let's calculate B1F. B1F, B1F, ये calculate करना है. Right, now let's see carefully. Can I write, children, from this, can I write OB1 plus B1F is equal to OF? Yes. Now what we have to find? We have to find B1F. So B1F is equals to OF minus OB1. OF is what? Focal length, but that is minus, so it is minus F. Minus OB1 is what? OB1 to image का distance है ना, minus V, that is minus V. So instead of B1F, we have put the value that is minus F minus minus V. So minus F plus V हो जाएगा, right? So after solving, after rearranging them, we will get this equation. Divide this equation with U, V and F and you will get this equation. Rearranging, we get the length equation, that is 1 by F equals to 1 by V minus 1 by U. Okay. Now children, let's talk about the linear magnification of the lens. Now magnification, we know that magnification is height of image upon height of object. Now suppose if height of image we denote by HI, then and height of object by HO, then it is HI by HO. Right. Now we have been using this equation in class 10th, right? We can show here, we can prove here. Let's see how. See, this is what we had done. The AB is the object and A dash B dash is the image. Now we know the triangles, that is ABO and A1 similar, so the ratio of the corresponding sides are equal. So these two sides are perpendicular. So A1 B1 upon AB upon the base. Base इसका क्या हो जाएगा? OB1 upon OB. So OB1 upon OB. Image ऊपर लिख रहे हैं and object नीचे, right? Now let's put their value. AB1 is what? AB1 height of image HI. AB height of object H0. OB1 is the B1 is the image where it is formed. So it is image distance. So that is on left, it is minus V. OB object distance, it is on left, so it is minus U. Minus minus cancel, so you get HI by H0 equals to V by U. Yes, children. Similarly, you can prove it for the convex lens also. So this is your magnification formula, that is M equals to height of image upon height of object equals to image distance upon object distance. Right, so remember the magnification formula. We are going to use it for numericals. Now next is your power of lens. Power of lens is the ability of the lens to converge or to diverge a beam of light that is falling on it. As we know, the converging lens, it converges light at one point. Diverging lens, it is going to spread out light, it is going to diverge the light. But with how much? So that power, that ability, kitna diverge karega, that is known as the power. So ability of lens to converge a beam of light that is falling on it is called power. And its SI unit, we know it's diopter, which is shown with the symbol D. Right? Power of lens, we know, we have studied in class 10 that it is reciprocal of the focal length. So P equals to 1 upon F. Right? Here, this is your lens maker formula. Right? Now children, here we are going to show that how the power for a convex lens is positive and for concave lens it's negative. Let's see how. See now children. For R1, the radius of curvature might be this side, so the right hand side is positive, and R2, the radius of curvature is this side, so that is negative. Right children? So that is negative. So if I put R1 positive here and R2 value negative, so negative negative ये plus हो जाएगा. So ये पूरा plus हो गया. So F की value क्या आएगी? Plus. तो focal length positive आएगा आपका. Right? और focal length positive आएगा तो बेटा power भी तो positive आएगा, because power is nothing, 1 upon F. Let's understand for concave lens. For concave lens, दिस इज योर R1. R1 नेगेटिव होगा, लेफ्ट हैंड साइड में है, और ये जो सेकेंड सरफेस है उसका R2 राइट हैंड साइड में पॉजिटिव होगा. लेट्स सब्स्टिट्यूट दिस वैल्यू इन द लेंस मेकर फॉर्मूला. सो R1 माइनस, ये माइनस है और ये प्लस है, तो माइनस प्लस, तो बेटा ये प्लस माइनस, तो इसकी जो वैल्यू आएगी वो आएगी नेगेटिव, राइट. सो फोकल लेंथ विल बी नेगेटिव एंड पावर विल बी नेगेटिव, राइट. सो F equals to P equals to 1 by F, and here comes the definition of one diopter. So one diopter is the power of the lens, जिसका focal length कितना होगा बेटा, 1 meter. So you can define diopter, one diopter as, one diopter is the power of the length with focal length 1 meter. Let's do the last topic for today, and that is combination of two lenses in contact. So children, we are doing the combination for various reasons. It might be to increase the magnification, it might be to reduce the errors, to reduce the defects that occurs when we are using a single lens, right? So here what you are doing is you are placing the two lenses touching to each other, that is they are in physical contact with each other, right beta? So here you can see that we are having two convex lens, L1 and L2. They are placed in contact with each other. So children, here O is the object, and suppose lens 2 abhi nahi hai, then the object O's image will be formed at I1. So for lens 1, if only lens 1 is present, the object will be O. So the object distance will be U, and the image distance will be this. The image will be formed at I dash, and that distance we are calling it as V dash, right? So the image distance will be V dash. But lens 2 bhi hai, so if lens 2 is also there, then object will remain at U only, but the image will be shifted from I dash to I, and the image distance and I dash will behave as a virtual object, and the image will shift from I dash to I, and so the image distance will not be V dash, but it will be V. This is for lens number 2, right? So children, here what we are having, the focal length of lens 1 is f1, focal length of lens 2 is f2. The combination दोनों का साथ में focal length f है. अब हमें लेंस इक्वेशन पता है, 1 upon f equals to 1 by v minus 1 by v. अब ये इक्वेशन हम लेंस L1 के लिए लगाते हैं, ठीक है, लेंस L1 के लिए लगाते हैं. लेंस L1 के लिए f की वैल्यू क्या हो जाएगी बेटा? The value of f will be f1, right? V is image. Image क्या है f1 के लिए? V dash. Object क्या है? Object तो U ही है. So this is equation number 1. I hope this is clear, right? Now let's apply the lens equation for L2. So L2 के लिए f कितना है? f2. V means image. Image कितना है? V ही है, right? Object इसका U नहीं है, क्योंकि इसको virtual object मिला था. That was I dash. ये I dash ने virtual object की तरह behave किया और इसकी image बनी थी. So इसका U की जगह हम लिखेंगे V dash. So if you add both the equations, on adding equation 1 and 2, you will get this equation, and further you will solve, and then you will, let's do it. Okay, so what we are doing, we are adding equation number 1 and 2. So children, when we add equation 1 and 2, we are going to get 1 upon f1 plus 1 upon f2 equals to 1 upon 1 by v dash, and minus 1 by v dash will get cancelled, and you are going to get 1 upon v minus 1 upon u. And 1 upon v minus 1 upon u is what? That is 1 by f. तो उसकी जगह 1 by f लिख दिया हमने. तो आ गया ना बेटा? 1 upon f equals to 1 upon f1 plus 1 upon f2. So this is the formula for combination of two lenses in contact with each other. And 1 upon f is power. 1 upon f1 is power of lens 1. 1 upon f2 is power of lens 2. Okay children, and this is our special case which we have done, that it depends upon the types of lenses, that if you are having both convex lenses If you're having both concave lenses, if first one is convex, the other one is concave, then according to that, the value of the focal length, the sign will change, and with the change in the sign, you are going to get the difference with the sign. Okay, this you can go through. This is very simple and fine. With this, we'll end our class here. Tomorrow we will continue with the next topic.